Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 5 from the Solomon J paper. This is from the C3 or now it's P3 collection. And this question here is about basically functions and differentiation. So the part that is concerning us in this particular video is the differentiation part. Okay, but I'm going to go through the whole of the question. In fact, the student who asked me a question about this was asking about part A, which is to deal with the range of functions. So here we have f of x is equal to 5 plus e to the power of 2x minus 3. And we're given the domain of this function as x is an element of all the real numbers. Okay, any value of x can be the input of this function. Now we want to state the range of this function. Now the range of a function is basically all the possible output values it can have. The domain is the input values and the range is what comes out after you've put those values in. So you want to find all the possible values of the output given the domain as being all real numbers. Okay, so what we need to do here in this type of question is to consider what type of function we have. So the basic function here is like e to the power of something. So let me call the basic function g of x. So g of x is e to the power of x. That's like the parent function, okay, the original parent function. And then some transformations were made to this for it to become like that. So what's happened first to this function is the stuff that's inside the function. It's like the stuff that's inside here. So first thing you've done is you've taken the g of x and you've replaced the x with 2x minus 3. Okay, that gives us e to the power of 2x minus 3. Now when you do this, when you replace the x with 2x minus 3, there's two things that are happening. Okay, and when you are dealing with changes that take place inside the function, you always deal with the things which cause, we deal with the opposite of BIDMAS. So we're dealing with the subtraction first. Okay, now if you have, something where you take something away from inside the function, like for example, if you have, f of x minus a, that causes a translation of one of a units to the right. It's a translation of a units to the right. So this is going to go 3 units to the right. And then when you have something like f of half x, what happens is that's a stretch, which is a horizontal stretch of 2 units. Okay, so basically, or factor 2, you could say. So here you're going to move, the whole function is going to move 3 units to the right. So all the x values will be, you add 3 to them, and then all the x values, you would divide them by 2. Okay, now as you'll realize that all of this just causes a horizontal change. It doesn't cause any vertical change. There's no vertical change from this. So that won't affect the range of the whole main function. It will just affect, x values and things will shift horizontally. What will affect the range of the function is what happens next when you have to add 5 to the whole thing. When you add 5 to the whole thing, this is when you're going to get 5 plus e to the power of 2x minus 3. Now this outside the function stuff, that affects the y values. And they act kind of normally. So when it was inside the function, it said minus 3, you go 3 to the right, kind of like, opposite of what you might think. And when you have 2 times x, you have a horizontal stretch factor of a half, the reciprocal of that. Now when we have, when we're dealing with things outside the function, they affect the y values and they kind of act normally. So here we're going to add 5 to all the y coordinates. So the range of the original function is going to now be changed by, is going to increase by 5. So what does the original function look like? What does the graph of y equals e to the power of x look like? Well, we should know it's a function which is called a exponential function. That is called the exponential function. And it goes through 0, 1. That's y equals e to the power of x. Right, so with these transformations, okay, what's going to happen is it's going to basically, what's going to happen is all the other changes that take place doesn't really matter. The most important change now is we're considering what happens on the y, like the lowest point it gets to. So the lowest point this gets to, it can always be above the x-axis. It can never go below the x-axis. So the asymptote is y equals 0. Now, if you make changes horizontally and so it doesn't make any difference to the vertical change. But if you now We try and get this in there. Okay, if you now add 5 to the whole thing after the other transformations that take place, so basically it's going to shift, first of all 3 spaces to the right, and then it's going to go 1.5 units to this side. So when it's like this, for example, when it's e to the power of 2x minus 3, when x is 0, then you have it's going to go through x is 0, it'll be e to the power of minus 3. Okay, so it's going to go through e to the power of minus 3 on the x-axis, on the y-axis. Doesn't matter. That doesn't really matter. What matters is what happens next when it's lifted up by 5 units. So the whole thing will lift up by 5 units. Let me just take this. 1 second. Let me take this down a bit so I can have a bit more space. Okay, so the whole of this is going to shift up by 5 units. Get this line, yes, I can get this line. Okay, so the whole thing will shift up by 5 units. All right, so the whole thing will shift up by 5 units. So now, before it couldn't go through, it couldn't hit y equals 0. Now the asymptote is going to be y equals 5. Now the asymptote is going to be y equals 5. So therefore, we can say that the range of this function is y is greater than 5. It's not greater than or equal to, it's greater than 5. Why? Because the whole function has lifted up by 5 units. Now, we don't have to go through all of this sketching and stuff like that, all of this kind of stuff. I'm just trying to explain the background to it. You can just write down, it says state the ranges. You can just write this down and you got your answer and you got your 1 mark. All right, very simple. But you have to understand what the main or parent function looks like and what its range is and how these transformations have affected it. So you can see that these things in here don't affect the range. These things do not affect the range of the function. Okay, they're all horizontal translations or transformations or stretches or whatever. What affects the range is what happens on the outside of the function. Things that are added to or multiplying the function. These are the things that affect the range. Okay, so the range is affected only by the things on the outside of the function. Okay, which is the thing, that 5 that's been added. So the range of the original function of this is y is greater than or equal to, just greater than 0. Okay, so the range of our final function is y is greater than 5. So there's the answer to 5 part A, which was a question that the student asked, but just for the sake of completeness, I will complete the whole question. So it says here, find an expression for the inverse of f of x and state its domain. Okay, so this is important now. We know that the actual function is f of x equals 5 plus, so f of x equals 5 plus e to the power of 2x minus 3. Yeah, and x, the domain of this function is all real numbers. And we know that the range of this function, which we just found, is y is greater than 5. Okay, this is the range. We figured that out. Now it says find an expression for now this is the inverse function. First point is many people, they mix up inverse and the differentiation, the first derivative, f dash of x. They mix up f dash of x and inverse of fx. They're 2 different things. So some people, they see this, they start differentiating the function. Sometimes there are people, they see this, they start finding the inverse of the function. They see this, they start differentiating the function, and vice versa. So you've got to be careful not to mix them up. The power to minus 1 means inverse, the dash means differentiate. So here we have to find the inverse. To find the inverse, I like to start off as following. Whatever the function is called, f of x, g of x, whatever it is, I call it y equals. So y equals 5 plus e to the power of 2x minus 3. And then what I like to do at this stage is replace the x with y and replace the y with x. Okay, so you have x equals 5 plus e to the power of 2y minus 3. I like to do this in the beginning because in the past I used to teach it doing it at the end, and what would happen is students would forget to change the y and the x at the end and lose marks. So if you do this right the first step, you can't forget. Okay, so now the next stage is to make y the subject. The first thing I will do is I will isolate that e term. So x minus 5 equals e to the power of 2y minus 3. And now I want to release this from the power. Okay, so what I'm going to do is I'm going to take the log to the same base of both sides. And what I'll do is I'll take log to the base e of both sides. Why? Because this will cause this to just become 2y minus 3. this side, and here log to the base e is the same as saying ln. So ln of x minus 5 equals 2y minus 3. Okay, so I'm just going to go through a little reasoning behind that. If I take the log of this side, okay, it's going to become ln of e to the power of 2y minus 3. Then I can use the power law. So 2y minus 3 times ln e. And we know ln e is like log to the base e of e, which gives you 1. That becomes 1, you're left with 2y minus 3. That's why when I take ln of both sides, you can just write down 2y minus 3 in your next line. But this is actually what's happening on this side of the equation. Okay, you've taken ln to the base e, or log to the base e, which is ln of both sides, use the power law, and log to the base e of e is 1, and we've got the answer. So now we have to make y the subject. So I'm going to add 3 to both sides. So I'll have 3 plus the ln of x minus 5 equals 2y. And then I'm going to divide both sides by 2. So in the end, we're left with y equals 3 plus the ln of x minus 5 all over 2. And that's your y value. So y is equal to 3. So we can say the inverse of the function. In the end, we should write it as inverse. The inverse of the function x is equal to 3 plus the ln of x minus 5 all over 2. We just make that a bit neater. It looks like a 3 now, doesn't it? Okay, you don't want to make silly mistakes like that. So there we have our answer for part B. Okay, and then it says state its domain. So that's also part of the answer. Now what we should understand is the domain of the inverse is the same as the range of the original. Okay, so that's why it says state, because we already found that. So we can say the domain is, now we don't write it as y, we write it as x, because the domain is x value. So we put x is greater than 5. So we use the same value that we found for the range, but call it x, that's all. Okay, so the domain of the inverse is always the same as the range of the original. And if you want to just to have a little think about this, if we draw this graph, it will be like 3 over 2 plus ln, or you could say a half of ln of x minus 5. Okay, if we were to draw this graph, what we should understand is the ln graph has this type of shape. Let me just make that a bit better. The ln graph looks something like this. When it's just y, because ln x will look something like this. It goes through 1, 0. So it's the reciprocal of the exponential graph, so it's like the reflection of y equals x. It'll go this way. Now, with these transformations, the first thing that happens is you add 5 to all the x coordinates. So this, including its asymptote, this one has an asymptote over here, by the way. This one has an asymptote over here, which is the y-axis is asymptote. Okay, so the whole thing moves 5 spaces to the right because this is inside the function, so it changes in that way. Okay, so the whole thing will move 5 spaces to the right. So this now becomes 6. Okay, and this now becomes 5. Right? That's the only horizontal transformation that takes place, which will only, that's the thing that will affect the domain. Everything else is going to be vertical. So, you know, the thing will lift upwards, or will be multiplied by a half and then lift upwards. So you all the y coordinates will be multiplied by a half, and then you add 3 over 2 to all the y coordinates. That won't affect the fact that there's going to be an asymptote here, and the graph won't be able to even, you know, touch 5. It will always be greater than 5. So we can see the domain is x is greater than 5. Because that's where the asymptote ends up. So you can see how it fits in with our understanding of the fact that the inverse of the function, its domain is the same as the range of the original. So you don't have to show this. I'm just giving you an idea of how, you know, it all fits in, the graphs and our understanding, okay, of the topic. So there's the answer to question part B, question 5 part B. This is question 10 from our end of topic worksheet. And then now comes a question where it says solve the equation f of x equals 7. So we're going to solve this equation. We're going to equate this to 7. So 5 plus e to the power of 2x minus 3 equals 7. So we have e to the power of 2x minus 3 equals 7 minus 5, which is 2. And then we can take the ln again of both sides, which gives us 2x minus 3 equals the ln of 2. Okay, and then we can say 2x equals 3 plus the ln of 2. And x equals 3 plus the ln of 2 over 2. Okay, so there's the answer to this question. I've left it in exact form. Okay, you could write it in decimal form, but I would suggest if it doesn't mention anything, it's best to just leave it in exact form. Okay, otherwise you can find that value of that by putting it in your calculator and write it to 3SF, but this I think should be perfectly good. Then the next part of the question says, find an equation for the tangent to the curve y equals f of x at the point where y equals 7. Now we've just found what x is when y equals 7. Okay, this is like saying y equals 7. So we've got the point, let's call the point P. We know the point, its x value is 3 plus ln 2 over 2, and its y value is 7. So that's the point where we have to find the equation for the tangent to the curve. All right, so before we can do that, we need two things. To find the equation of a tangent. Now, tangent is basically a straight line which has or shares the same gradient of the curve at the particular point. So if the curve goes something like this, okay, then a tangent would be a straight line which just touches the curve, okay, at the point where we're trying to find the gradient. Okay, it just touches the curve at that point. So this is the point P. We have to find the equation of this tangent. So the equation of a straight line, which the tangent is, you need a point on the line, which we have, and we need the gradient of that tangent. Okay, to find the gradient of the tangent, we should understand that where the tangent touches the curve and the tangent, they share the same gradient. So the gradient f dash of x, first we need to find, which is going to be by differentiating this. You differentiate 5, it becomes 0, it's just a constant. You differentiate e to the power of something, it stays the same. Doesn't change. That's one of the things about e to the power of something. It stays the same. However, then you have to multiply it by the differential of whatever's inside the function. If there's a function inside the function, you use the chain rule. So we're multiplying by the 2 here. So we're left with the gradient function is equal to 2 times e to the power of 2x minus 3. So we want to find the gradient when x is equal to 3 plus ln 2 over 2. Now, it might be tempting now to write this as a decimal and work this out, but you'll see how this works out nicely for us. So don't fall to that temptation. Just keep it in its original form and you'll see how it makes life easy for us. We're going to have 2 times e to the power of, and then we're going to put, instead of x, we're going to put this. So we have 3 plus ln 2 over 2, and then we're going to take away 3 from that. Okay, this is replacing the x with 3 plus ln 2 over 2. Now what happens here is the 2's cancel out. So you're left with 3 plus ln 2 minus 3. The 3 minus 3 is 0. So you're left with 2 times e to the power of ln 2. Now, e to the power of ln 2 is basically the same as saying 2. Because it's like these two are inverse functions of each other. You know, e to the power of x and ln x are inverse of each other. So they cancel each other out. When you put one into the other, when I say f of f minus 1x, that just leaves me with whatever is in the bracket. Okay, so it's like you've got a function and you have the composite function with 2 in there. They cancel each other out. You're left with just 2. E to the power of ln 2 is equal to 2. Okay, so that's one of the things that we should understand. All right, so now that's going to give me 2 times 2, which is 4. So we know that the gradient of the tangent is equal to 4. So we have our point, which is 3 plus ln 2 over 2. 3 plus ln 2 over 2 for the y or x coordinate, and 7 for the y coordinate. And we have the gradient of our tangent, which is 4. So we know that we can use y minus y1 equals m times x minus x1. You can also use y equals mx plus c if you want, but I like to use this. So y minus 7 equals m, which is 4 times x minus 3 plus ln 2 over 2. Okay, so you have y minus 7 equals 4x minus, and you're going to, these cancel out, you're left with 2, so it's going to be 6 plus 2 ln 2, because you cancel, when 4 multiplies with this, the 2 and the 4 cancel out, you have to multiply this by 2. Okay, be careful here. Let's just do this step by step. This acts like a fraction bar, like a bracket, so be careful. You have minus 4, and you have 3 plus ln 2 over 2. I do advise that you don't rush like I did, because the signs will be affected by this and you'll mess up. Okay, so when you're doing this, do it step by step, because of this fraction bar is like a bracket, so you be careful. So you have y minus 7 equals 4x. and then this is going to cancel with this, leave you 2. Then you've got minus 2 times 3, which is minus 6, and minus 2 times ln 2, which is minus 2 ln 2. So now we can rearrange it if you want to say y is equal to 4x, and you're going to have minus 6 plus 7, which is plus 1 minus 2 ln 2. You can leave the answer like that. You can write it as 4x minus y plus 1 minus 2 ln 2 equals 0, whatever. There's different forms you can write it in, but this is perfectly fine. And there is the answer to question part D, and that completes this question. I hope that was clear. I think the student who asked me only had a problem with part A. Okay, that's because of the stuff from transformations that we have to remember. But part C and D and B I did as well. Other questions from this particular paper, the Sullivan J paper, can be found in the playlist that will appear in the top right of the screen at the end of the video. Other questions from this end of topic worksheet number 5 from my P3 collection can be found in the playlist that will appear in this region of the page. Other questions from P3 differentiation from my Cambridge collection can be found here, and from my Edexcel collection can be found there. Thank you for watching. See you soon.